Hello, pre-algebra students. This is Chapter 4.6, Negative and Zero Exponents. Thus far in pre-algebra, we've been working with positive exponents. Let's consider the following pattern of powers of 2 to help us understand how negative exponents might work. 2 cubed is equal to 8. 2 squared is equal to 4, or half the value. 2 to the first power is 2, or half the value of 4. 2 raised to 0 is going to be half of the exponent above it. So, believe it or not, it will be 1. 2 to the negative 1 will be half of 1, or 1/2. 2 to the negative 2 will be half of 1/2, or 1/4. We can express that law like this. For any non-zero number a raised to 0 power equals 1. For any non-zero number a and any integer n, a raised to negative n will equal 1 over a to the n power. Let's work through some examples so you can understand how these laws work in practical practice. Let's begin with 3 to the negative 5th power. Let's rewrite this expression so it uses only positive exponents. Since our original rule is that a raised to n, negative n, equals 1 over a to the n, we would rewrite this as 1 over 3 to the 5th power. Let's try this with another problem. M to the 0 and n to the negative 4. Let's rewrite it so it only uses positive exponents. M raised to 0 will be 1, because a raised to 0 is always equal to 1, times n to the negative 4, which will then be rewritten as 1 times 1 over n to the 4th. Let's try one more example. 16 x to the negative 6th y. If we want to rewrite this using only positive exponents, it would become 16y over x to the 6th power. Practice applying these laws on your own now. Rewrite each expression using only positive exponents. Press pause while you work and come back for the next idea when you're ready. You can also use prime factorization of a number to write a fraction as an expression involving negative exponents. Let's try this. Let's rewrite 1/16 as an expression without using a fraction bar. So we'll begin by writing the prime factorization of 16. 1 over 2 times 2 times 2 times 2. Or 1 over 2 to the 4th power. So now we can write this without using a fraction bar by writing it as 2 to the negative 4th. Because remember, anytime we have a raised to negative n power, it equals 1 over a to the n. So we're simply reversing that here. We're taking our 2 to the 4th power and making it 2 raised to negative 4. So 2 raised to negative 4 is equal to 1/16. Now let's work through another example. A squared over c cubed. How could we rewrite this expression without using a fraction bar? A squared will stay exactly where it is and look exactly the same way. And to express 1 over c3, we'll write c to the negative 3 power. So a squared over c cubed becomes a squared times c to the negative 3 power. Now try these 4 on your own. Write these expressions without using a fraction bar. Use what you've learned about negative and zero exponents to rewrite the expressions. Press pause while you work, and we have one more idea to cover when you come back. We can use the product of powers property and the quotient of powers property to find products and quotients that involve negative exponents. Let's try this problem. 5 to the 10th times 5 to the negative 6th power. First, we use the product of powers property, which tells us that we add the two exponents. So 5 raised to 10 plus negative 6 would give us 5 to the 4th power. Now let's work through this example. 8/10 n to the negative 3rd power divided by n squared. Using the quotient of powers property, we know that we'll take 0.8 times n to the negative 3rd minus 2, giving us a final answer of 0.8 or 8/10 n to the negative 5th power. We can rewrite that now in fraction form to get rid of our negative exponent as 0.8 over n to the 5th power. Okay, now work on putting this all together. Find the product or quotient in each of these problems for number 9 through 16. Write your answer using only positive exponents. So make sure you're using what you know about zero and negative exponents and the laws that govern them to make sure that you don't have any negative exponents in your answers. Please press pause while you work. There is one last problem to work through together before we're finished with chapter 4.6. Let's close out this chapter with one final example. We're going to solve a problem that involves negative exponents. Geckos can easily climb smooth vertical surfaces. Biologists have discovered that tiny hairs are the reason that the feet of a gecko are so sticky. Each hair is about 100 micrometers long. A micrometer is 10 to the negative 6th meters. What is the length of one hair in meters? To find the length of one hair in meters, we're going to multiply the length of the hair in micrometers by the number of micrometers in 1 meter. Each hair is 100 micrometers long. And we're going to multiply that length by the number of micrometers in 1 meter, which is 10 to the negative 6th. To solve this problem, we need to rewrite 100 as 10 squared so that we're able to work with the exponent. So now we have 10 squared times 10 to the 6th. Let's use our product of powers property, 10 squared plus negative 6. We'll add our exponents to get 10 to the negative 4th. We want to change our negative exponent, so we'll have 1 over 10 to the 4th power. And then we'll answer and evaluate by taking 10 times itself 4 times, giving us 10,000. So each hair is 1/10,000th of a meter in length. All right, folks, that's all for today. I'll see you tomorrow to do more work with negative and zero exponents. Have a great night.